Everyone, and welcome to the Curious Calculator. Today we're going to be going over the following problem. Graph the following rational function. Y equals x squared plus x minus 2 over x squared minus 4x plus 3. Alright, so I'm going to go about this problem by following this four-step method I have here that I would recommend to anyone going about these problems. If you follow these steps, graphing these rational functions should be a bit easier. Alright, so let's see here. Let's start with step number 1. We want to simplify and identify any holes. So in order to do that, what I'm actually going to do is I'm going to factor both the numerator and the denominator here. So this is going to become y equals, factoring the numerator, we're going to get, let's see here, x, that multiplied to negative 2 and add to 1. That should be, let's see, a positive 2 and x minus 1. And then in the denominator here, we want two numbers that multiply to positive 3 and add to negative 4. And so that's going to be, let's see here, x minus 3 and x minus 1. Alright, so now let's notice here that we have a x minus 1 factor in the numerator and an x minus 1 factor in the denominator. So we can go ahead and cancel those out. And that is actually going to be where our hole is. So when we rewrite this, we got to keep that in mind. So we can say y equals x plus 2 over x minus 3. And let's note here that x cannot equal 1. Alright, awesome. So now we found our hole, we simplified, and let's move on to step number 2. Step number 2, we want to identify the x and y intercepts. And so let's see here, the x-intercepts are going to occur when y equals 0. And for y to equal 0, we're going to need our numerator here to be 0. And so let's see, when x equals negative 2, we'll have negative 2 plus 2, which will give us 0. And that'll result in the whole rational function being 0. And so we're going to get that our x-intercept occurs at negative 2, 0. And then the y-intercept is going to occur when x equals 0. And plugging in 0 for x, we're going to get 2 over negative 3, which will be a y-intercept at negative 2 over 3. Alright, awesome. We completed step number 2. Now we're going to move on to step number 3, identify the asymptotes. Alright, so the asymptotes, let's look for vertical asymptotes first. Vertical asymptotes. Alright, now the vertical asymptotes are going to occur when our denominator equals 0. And so in this case, our denominator will equal 0 when x equals 3. So we're going to have a vertical asymptote at x equals 3. And notice that I'm not saying that x equals 1 is going to be a vertical asymptote, because that will be a hole. And that is different than a vertical asymptote. Alright, so let's see. Let's do horizontal asymptotes. Horizontal asymptotes. And now, let's see. We have 3 cases here for horizontal asymptotes. The first case is that if the degree of the numerator is larger than the degree of the denominator, then we're not going to have any horizontal asymptotes. If the degree of the numerator is the same as the degree of the denominator, then our horizontal asymptote is going to be found by comparing or by looking at the coefficients on the leading terms here and writing them as a ratio. So in our case, the leading coefficient is 1 for the numerator, and the leading coefficient for the denominator is also 1. So that means that we are actually going to have a horizontal asymptote at y equals 1 over 1, which equals 1. And in the last case that I hadn't gotten to is if the numerator, the degree of the numerator is less than the degree of the denominator, then we're going to have a horizontal asymptote at y equals 0. Alright, but for this one we fell into the second case there. We found our horizontal asymptote. Alright, so I think, and then, in slant asymptotes, that will occur if the degree of the numerator is exactly 1 more than the degree of the denominator. But for this example here, the degrees of the numerator and denominator are the same, so we're not going to be having any slant asymptotes. Alright, so we finished up with step number 3. So now let's go ahead and create a sign chart here. So sign chart, what we want to do is we want to draw a number line, and on this number line we want to put labels for our x-intercept, which is at -2, and then also our vertical asymptote at x equals 3. And that's going to be the case always when you make this number line. On the number line you want to put the values for your x-intercepts, whatever they are, and then also your vertical asymptotes, and then we're going to identify whether the function is positive or negative in each of these intervals here. Alright, so if we plug in, for example, -4, then into our original function, then we're going to get -4 plus 2, which is going to be -2 over, and -4 minus 3, which will be -7. So that's going to be a negative over negative, which will give us a positive. Alright, so for this middle region, if we plug in, let's say 0, then we would get a 2 over -3, which is going to be negative for this region. And if we plug in a positive 4, we're going to get 4 plus 2, which will be 6, and a 4 minus 3, which will be 1. And so in that case, we're going to have a positive over a positive, which will then give us a positive here. Alright, awesome. So we found our sign chart. So now we can go ahead and graph this function out. And I'm going to go ahead and do that right here. So right here we can say that, well, let's draw our x-intercept -2 and our, vertical asymptote at x equals 3. And then we're going to have a horizontal asymptote at x equals 1. So I'm going to kind of draw some dotted lines for these asymptotes here. Okay. And then now, because we have our sign chart, we can fill in the graph here. And so when we're to the right of 3, we're going to be positive. So that means our function is going to have to look something like so. We're following along those asymptotes there. And then when x is between -2 and 3, it's negative, and then it becomes positive after crossing through that x-intercept there at -2. So we're going to start out down here, and we're going to come up and kind of cross over and then follow along this asymptote right here. And that will complete this problem. That will be our final answer here. This graph. Alright. Awesome. And I'd like to finish today with a little fun fact from philosophy. Did you know that Pythagoras and his followers, the Pythagoreans, believe that all is number? And they applied this to music. So they found that harmonies were produced by certain ratios, such as 1 to 2 and 2 to 3. And they didn't stop there. They actually went and they looked to the heavenly bodies in the sky and said that even the motions of them created harmonies.